All right, today we're tackling a really fundamental topic, descriptive statistics. We're going to explore how it helps us turn messy, raw data into clear, compelling stories.
So, picture this. You've got a ton of data. Maybe it's from a survey, an experiment. I don't know. Maybe you're just tracking numbers. It's just this big pile of raw information. The huge question is, now what? I mean, how do you even begin to make sense of all that?
Okay, let's make this real. Imagine a company wants to figure out how its employees commute. So they send out a survey, and what they get back is this long, kind of messy list of answers, right? Car, walk, public transport, bicycle, car, you get the idea. Just looking at that raw list, good luck finding any real pattern. It's just noise.
And this is where descriptive statistics swoops in to save the day. Think of it like a toolbox. It's full of tools we can use to summarize and describe all that raw data in a way that actually means something. The whole point is to give us a simple, clear snapshot of what the data is trying to tell us.
Now, we need to be super clear about something right up front. There are two main types of statistics. We're talking about descriptive statistics. All that means is we're just describing the data we actually have, for this one specific company. We're not dipping our toes into the other kind, which is called inferential statistics. That's where you try to make big guesses about a whole population, like all employees in the country based on your small sample. Nope. For now, we're just focused on the data we can see right here in front of us.
All right, so where do we even begin describing this data? Well, the first thing you usually want to do is find its center. We're basically asking, what's a typical value? What's the normal in our data set?
And it turns out we've got three main tools for the job: the mean, the median, and the mode. I'm sure you've heard these words thrown around before, right? But let's really break them down. We'll look at what each one really tells us, and, more importantly, when you should use one instead of the others.
Okay, first up is the mean. This is the one you definitely know. It's just the average. All you do is add up all the numbers and divide by how many numbers you have. Super simple. You see these 5 test scores? Add them up, divide by 5, and boom, you get a mean score of 86.6. Easy peasy. Next, we've got the median. Now, this one's all about finding the exact middle. You just line up all your numbers in order, from smallest to largest, and find the one that's smack dab in the center. Now, if you have an odd number of data points, it's easy. It's the one right in the middle. If you have an even number, no big deal. You just take the two middle numbers and find their average.
So, mean versus median. When do you pick a side? This is where it gets interesting. Look here. On the left, you've got a pretty normal group of heights. The mean and the median, they're the same. No drama. But check out what happens on the right when we throw in an outlier, a ridiculously tall person. The median, the person who's literally in the middle of the line, doesn't budge. It stays at 175. But the mean? Oh, it gets totally yanked upwards by that one extreme value. This is the superpower of the median. It's resistant to outliers. It's exactly why you always hear about the median home price, not the mean. It stops a few mega mansions from making it seem like everyone lives in a palace.
And our third tool for finding the center is the mode. This one's the easiest of all. It's just the value that shows up the most often. That's it. Sometimes you have one mode, that's called unimodal. Sometimes you have two, we call that bimodal. And yep, sometimes nothing repeats, so there's just no mode. Now, going back to our commute survey, the mode is perfect because our data isn't even numbers. It lets us find the most common answer, which is exactly what we want to know.
Okay, so we've nailed down the center of our data, but that's really only half the picture, isn't it? Knowing the typical value is great, but now we need to know about the spread. Are all the data points huddled up together, or are they scattered all over the map?
And for this, our go-to tool is the standard deviation. Now, don't get scared off by the name or the crazy-looking formula you might see in a textbook. The idea behind it is actually pretty simple. It's basically the average distance that each data point is from the mean. So a small standard deviation tells you everything is tightly packed together. Think of a super consistent basketball player who scores 19, 20, or 21 points every single game. A large standard deviation, that means the data's all over the place. That's your wildcard player who drops 50 points one night and then only 2 the next.
And hey, if you want something even simpler, there's always the range. It's literally just the difference between the highest value and the lowest value. It gives you a super quick back-of-the-napkin idea of the total spread.
But why does this spread stuff even matter? This example with blood pressure makes it so clear. Let's say the mean blood pressure for your patients is normal. Great, right? Well, maybe not. The standard deviation is what tells you the rest of the story. Are all your patients' readings pretty similar and close to that average? Or are some dangerously high and others dangerously low, and they just happen to average out? Knowing both the center and the spread gives you the full, and in this case, a potentially life-saving picture.
All right, we've found the center, we've measured the spread, we're getting a really good feel for our data. Now for the fun part. Let's get into organizing and visualizing it to make that story we're uncovering totally crystal clear.
So, let's jump back to our employee commute survey. Remember that messy list? The first step to cleaning it up is to organize it into a frequency table, just like this. It's a really neat way to just count up how many people chose each option. Okay, 11 people drive, 9 take public transport. You see it. This is way better, right? It's organized. But we can make it even more obvious.
And here it is, the magic of visualization. The second we turn that table into a simple bar chart, the story just pops right out at you. Instantly, you see that car is the winner. There's no thinking involved. Our brains are just built to understand pictures like this way faster than a table of numbers. And this is just a basic bar chart. Think about what other charts could show us.
Okay, that's perfect for looking at one thing at a time. But what happens when things get a little more complicated? What if we want to see if there's a connection between two things, like not just commute type, but commute type and which office they work at?
For a situation like that, we bring out a tool called a contingency table. You'll also hear it called a crosstab. It's pretty clever. You just put one variable in the rows, here that's the commute type, and the other variable in the columns, the factory location. Then each little box, each cell, tells you the count for that specific combo. So you can see right away, okay, 6 people in Detroit drive cars, while 3 people in Cleveland ride bikes. It's an awesome way to spot relationships between two different things.
Okay, let's take a step back and pull all these pieces together. Let's look at the big picture of how you tell your data story, from start to finish. So, what we've really done here is build a complete toolkit for descriptive statistics. It's like a 4-step process. Step 1, find the center. What's typical? Step 2, measure the spread. How much variation is there? Step 3, organize the mess into tables. And Step 4, the grand finale, visualize it with charts to make the story pop. And here's the bottom line, the thing to really remember. Descriptive statistics is about more than just crunching numbers. It's about giving your data a voice. It's how you turn a spreadsheet of gibberish into a clear, simple story that anybody can get. So think about where we started, with that messy list of commute answers. And by using these tools, we've totally figured out the story for this one specific company. We know what's most common, we see the whole breakdown, and we can even see how things differ between locations. Mission accomplished.
But solving that puzzle just leads to an even bigger question, doesn't it? We know everything about this company, but what does any of this tell us about commuters everywhere? Can we make a bigger conclusion? Well, answering that question takes us beyond just describing our data and into the really cool world of inferential statistics. And that, well, that's a story for another day.